Assalamu alaikum students. In our last lecture, we have studied atomic size and shielding effect with reference to the nuclear attraction. Today we are going to study ionization energy, electron affinity, electronegativity. What is the effect of atomic radius and shielding effect on periodicity of properties? Think about it. Today, our objectives are to understand ionization energy, electron affinity, and electronegativity, along with their trends, periodicity in their properties, and their relationship. What is ionization energy? According to the definition, the amount of energy required to remove an electron from the valence shell of an isolated gaseous atom is termed as ionization energy. It is the tendency of an atom to form cation. First, ionization energy. If there is only one electron in the valence shell or more than one electron, the energy required to remove one electron from the valence shell is called first ionization energy. For example, the first ionization energy of sodium is plus 496 kJ per mole. When sodium is in the isolated gaseous form, i.e. only one atom of sodium in the gaseous form, then it releases its one electron by absorbing 496 kJ per mole. That means 1 mole of sodium atom required 496 kJ energy to change into cation by removing its one electron from the valence shell. Plus sign indicate absorption or requirement of energy, or you may say addition of energy. What is second ionization energy? Students, if there are more than one valence electron, after removal of first electron, valence electron become closer to the nucleus due to increase in effective nuclear charge. Because the number of protons remain same, but by a decrease of number of electrons, the nuclear attraction increases and it pulls more strongly the remaining electron towards itself, and the atomic size reduces by the removal of first electron. So, removal of second valence electron requires greater ionization energy as compared to the first one, because the remaining electrons are closer to the nucleus and they require higher energy. That's why second ionization energy is always higher than the first ionization energy. For example, when we look at the ionization energy of magnesium, magnesium has 12 electrons and 2 electrons are present in its valence shell. It also has 12 protons in its nucleus. First ionization energy of magnesium is 737 kJ per mole. After removal of first electron, remaining 11 electrons are pulled closer to the nucleus as nuclear attraction is still of 12 protons. So removal of second electron becomes difficult due to greater nuclear attraction. So removal of second electron requires 1450 kJ per mole energy, which is greater. By removal of second electron from magnesium, its valence shell is also removed because there are no electron left in the valence shell. So atomic size also reduced from third shell to the second shell. In this case, if we are going to remove third electron from the valence shell, then it will require 7732 kJ per mole, which is nearly impossible. That's why removal of third electron in case of magnesium is impossible. What is the trend of ionization energy along the period? You know, as we move from left to right in a period, the value of ionization energy increases, because the size of atom reduces along the period. Valence electrons are held strongly by the electrostatic force of attraction due to smaller size, which require greater energy to remove valence shell electron. So when we see at the ionization energy of second period elements from lithium to neon, lithium require only 520 kJ per mole for the removal of first electron, but neon require 2081 kJ per mole. Let's have a comparison of two elements in a period. For example, first ionization energy of sodium and magnesium. The symbol of sodium is Na and magnesium is Mg. Sodium has 11 electrons in its valence shell and magnesium has 12 electrons in its valence shell. Atomic size of sodium is 186 picometer, while atomic size of magnesium is 160 picometer, which is smaller than the sodium. As you already know that atomic size reduces along the period. So when we try to remove one electron from sodium, as it is bigger in size and electrons are away from the nucleus, so it requires only 496 kJ per mole. But when we try to remove one electron from the magnesium valence shell, as it is smaller in size, it requires 738 kJ per mole energy to remove. So ionization energy of sodium is less than that of magnesium. Let's try to understand ionization energy down the group. Down the group, the size of atom increases. Valence electrons are held loosely by electrostatic force of attraction of nucleus. Also down the group, there is more shielding effect due to greater number of shells. So, valence shell electron becomes far away from the nucleus and it requires lesser energy to remove valence shell electron and make cation formation. For example, when we study the ionization energy of first group elements from lithium to cesium, lithium requires 520 kJ per mole, while cesium, which is bigger in size, requires only 377 kJ per mole. The question is, why cesium requires little energy to release its one valence electron? Cesium has atomic number 55. It belongs to fifth period as it belongs to first group. So its valence shell must have one electron. So remaining electrons are in the inner shell. So we can say that the greater number of inner shell electrons, 54, have greater shielding effect to the valence electrons. And that's why the hold of nucleus becomes weak. So valence electron is far away from the nucleus due to bigger size and feel less nuclear attraction. That's why cesium requires little energy to release its one electron present in the outermost shell.